This procedure is to explain the permeability of red blood cell slab. At your station, you should have a 5 milliliter pipette with a green tip or green pump, a P200. Again, the P200s measure 200 microliters. So we have the hundreds place, tens place, and ones place. So this one, if you look at it carefully, is set for 150 microliters. You should have pipette tip disposal, pipette tip boxes, and this is a 1 milliliter pipette with a blue pump. Now, the 1 milliliter pipettes are the same as the 5 milliliter pipettes. There is dead space right here at the bottom. So this space is not a milliliter. You do not dispense there. You should also have a spec 20. You should have DI water. You should have a sample vial. This one already has something in it. And you should have 500 osmol solution of a solute. This one is urea. Now you're going to have to obtain 5 cuvettes as well from the back. Try to get ones that don't have the texturing on the side. The first thing you are going to do is you're going to go to the back counter and you are going to obtain your sample solution. So you grab this and you go to the back counter. So you are going to obtain 0.25 milliliters or 250 microliters of blood. You are going to use a P1000 to do that. The P1000 has 3 numbers. The top number is red. It is milliliter, and it only goes to 1. That is the hundreds place, that is the tens place. So this one right now is reading 150 microliters. So to change this to 250, you use the dial here, and you rotate the dial until it reads 0, I hope I'm not making you dizzy, 25. So now that reads 025, that is 250 microliters or 0.25 milliliters. You load these just like you would load any of the other ones. These use a bigger pipette tip. You take the blood, you tilt it sideways, you go down 1 stop only, you drop the blood, you put it in, you should tilt this at an angle, then go down 1 stop, go down the 2nd stop. You are then going to get 2.5 milliliters of physiological saline. This is a saline solution whose osmolarity is 288 milliosmoles, and it matches the osmolarity of our red blood cells. So we're just diluting the sample down and actually giving it more volume in here as well. So again, with the 5 milliliter pipettes, this distance, we don't know what it is. That is not a valid measurement. So we are going to go up for 2.5 milliliters. 5 to the 4 is 1, 4 to the 3 is 2, then to the half. So 2.5 milliliters is again 1, 2, and the half. So it's the half mark between the 2 and the 3. A lot of students in this lab actually go to 2.5 here, which is too much. So we use the dial, we go to the 2.5, and again, like the last time we used these, we do not press this, we do not press this. We use the dial to dispense, and you go until you reach the 5. Go carefully until you reach the 5. And then you stop, because again, we do not know what that volume is. So, we then take the blood, we mix it with the cap on, and we go back to our stations with 5 cuvettes. You are now going to be making a series of 6 serial dilutions. You're going to obtain basically 6 different solutions of different osmolarities, and you're going to put the red blood cells in it and see what happens to the flux of water. So 288 right here is our control solution. That is isotonic to red blood cells. 350 and 500 milliosmoles are hypertonic to red blood cells. So in an impermeable solute, water will leave the red blood cells and the cell will shrink, and that actually reduces transmittance through the red blood cell solution. Here we have 3 hypotonic solutions. That means there's more water outside than inside. Water rushes into the red blood cells, and you actually have an increase in transmittance through the solution. So basically, we're going to have these 5 solutions, put red blood cells in, and if it's an impermeable solute, the percent transmittance will change. If it's a permeable solute, the percent transmittance doesn't change. So follow the instructions to make the solutions. You should have a 500 milliosmol stock solution and DI water. Put the DI water in first, and to do that, you can use either the 5 milliliter or the 1 milliliter pipettes. If you choose to use the 5 milliliter pipette, there is dead space right here. Never pipette out that. And again, you're going backwards for numbers. So from 5 to 4 is 1 milliliter. 4 to 3, so if you fill it up from 5 to 3, it is 2 milliliters. These little hash marks are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths of a milliliter. So you can use those. But since a couple of them are 1.2 milliliters and 1.8 milliliters, you might want to use the 1 milliliter pipette. So again, like the 5, there's dead space. But the 1 milliliter pipette lets you measure more accurately in tenths of a milliliter or even smaller units. From here to here is 1/10 of a milliliter. From here all the way up to the 0 is 1 milliliter. So if you need 0.2 milliliters, you can measure it more accurately on this pipette than on the 5 milliliter. So it's up to you which one you want to use. Now, once you've made your 5 stock solutions, so I've made 2 of them right here, you then are going to put the solutions in the Spec 20. It should already be on. And this one was unplugged last night, so it's basically on its default settings. So first of all, it's set for absorbance. We want transmittance today, so we press this button, ACT, until it goes to transmittance. Then this is wrong. According to the instructions, it is 510 nanometers, so we press that button to lower it down to 510 nanometers. You are now going to put the samples in. So this sample, it is our stock solution. It is the 500 milliosmol one. Now there's a problem with this cuvette though. This cuvette is a special cuvette. It has a textured side there, a clean side there. So when you put it in, make sure you're putting it the clean side through, not the textured side through. What you're going to do is you're going to open it, you're going to put the solution in, and you are going to hit 100% transmittance. So the 100% transmittance button. And this is going to zero out our solution. You are then going to take out the cuvette, and you are going to put in a sample of blood. To do that, you're going to be using the P200. Again, the P200 has 3 black numbers, and hundreds place, tens place, ones place, it is supposed to be set for 150 microliters. This is set for 150 microliters. So you open it up, you get your tip. We are now all experts at pipetting by now. You shake this one last time to be sure. You tilt it, put the tip in, go down only one stop, pipette your sample, quickly take the cuvette out, put in the blood, go down 2 stops, and you should shake it a little bit. I'm going to use my thumbs. We do have parafilm in the back to put on the top, so you can shake it that way. Put it in again so the light does not go through the opaque sides. And record the first number. So this one has 52.4% transmittance. You then repeat with the second qubit. So I'm taking this one out. I'm going to put this in, and if it does not go back to 100% transmittance, I'm going to hit 100% transmittance. It's at 100% transmittance, so I got very lucky that time. I am then going to take my sample again, go down 1 stop. I am going to draw up my blood sample. Again, only go 1 click down, remove it, then take out the sample, put in the blood, and you should put it down and close it. And then I record the transmittance. Now, good pipetting skills, you should eject the pipette between each one and get a new tip each time as well, which I forgot to do that. So make sure you change the tip each time as well. And then you are going to calculate the percent of the original size. The night teacher already wrote this up on the board, so I will show you what he wrote. To find the percent of original size, you divide the percent transmittance of each solution by that of the control solution. Our control solution is the 288 milliosmol solution. So you divide each percent transmittance by the control solution. And if the numbers remain about the same, about 5% here, so if the percent transmittance only shifts 3 or 4%, it means it's permeable. If it's greater than 5%, or if they're going all over the place, it means it's impermeable. Some of the solutions, the obvious ones, it's very obvious that it's impermeable. A couple of them are iffy. So I have some data right here. For the 500 milliosmol solution, I have 50% transmittance. For the 350, 67%. For the 288, I have 75% transmittance. This is our control. So everything you're going to be dividing by 75 in this case. So I'm going to put /75, /75, /75. So the first one, I am going to divide the 50% transmittance by my control, which was 75% transmittance. So I'm going to do 50 divided by 75 and use my calculator. I'm then going to do 67% transmittance divided by 75% and use my calculator. This one I can do in my head. We're dividing the control by itself, so it should be 100% transmittance, and so forth. You will then share your data on this computer in the front, and the results will be posted for you. Thank you.